Let's talk about autonomous differential equations. Graph the slope field for the differential equation dy dt equals y squared minus y minus 2 for y between -3 and 6. We could do this by hand, but it's much easier if you use some slope field generator. So just enter slope field generator into a search engine like Google, and you'll end up with something like this. You just enter these, enter this. Okay, we got y squared minus y minus 2. You've got these, these bounds here. We end up with a graph that looks like this. If we zoom in, we end up with a graph that looks like this. So pretty slick. Note that the solution does not depend on the t value. So for a given y coordinate, all the line segments will have the same slope. Okay? So notice this, that doesn't have a t in it. So as long as the y coordinate's the same, the line segments are going to have the same slope. So all of these have the same slope, all of these have the same slope, all of these have the same slope. It depends just on y, not on t. Differential equations that are of the form dy dt equals some function of y are called autonomous equations. That's because they're autonomous, they're independent of t. They don't depend on t. Let's sketch some solution curves. Well, you can just plot the points. If you just use your clicker, use your mouse to click on various points, you end up with something that looks like that. Note what happens when the curve passes through 0, 2, or 0, -1. The solution is constant, okay? So it's not going up, it's not going down, it's just straight across. A constant solution is called an equilibrium solution. It doesn't change, it never changes. It stays there. In fact, we could have found the equilibrium solutions to the autonomous differential equation dy dt equals f of y without even graphing the slope field. How? By determining where f of y equals 0. So again, our differential equation is of the form dy dt equals f of y. In this case, this is our f of y. So let's figure out where f of y is 0. We have y squared minus y minus 2 equals 0. Factor that, we get this. And so the two solutions are going to be y equals 2 and y equals -1. And those are the equilibrium solutions we saw earlier, y equals 2 and y equals -1.